All right, day 6 of this ACP review. Today, what I'm going to start off with is a graphing piece, and specifically a piecewise defined function as shown. It says which equation accurately describes this graph. Now, if you want to do by algebra, what I would tell you is whenever you see a closed dot like this, a closed dot means that the symbol, if you have more ink to fill in the dot, the symbol itself will need more ink like this. And remember, the symbols are always going to open to the right. And how you can know that is if you press the preferences here, you can see the Desmos, you'll see that they always open the right. That no matter what, they're going to open that way. Now, whenever you see this piece here with more ink, you need to have a line underneath. So this first piece of graph, since this is the right side, the stopping side should have a line underneath, meaning a line that way. Now, it doesn't have a left stopping, so the first one shouldn't have a piece at all. But if you looked at that, you could figure out your answers really quick. So I'm looking at just the first equation on both A, B, C, and D. And what I can find is the only one that's correct here is going to be answer choice B. That's the only one that has less than or equal to. That's a less than, greater than, or equal to. So it's going to have to be B. Well, let's just start graphing these, and I'll show you how they work as we go. And by the way, on the second piece, because this is less ink here, being open, it would have a symbol this way. And this one would be closed, so less than or equal to, with the X in the middle. So here you'd have an X in the middle, and there is no, you don't have to include the infinity, so you don't have to do the less than infinity since there's not a dot there. You could just leave it like that on that one. So anyways, an answer should be B. Let me show you how to type these in. When you type in piecewise, you're going to type the restriction after the equation. So if you can't remember the algebra, how do you do the graphing? You type the restriction after the equation. So I'm going to type this in. I won't even type in the f of x portion. I'm just going to type in negative parentheses. We have x plus 2, x plus 2. This is raised to the power of 2 or squared. And then a plus 4. Now, in place of the comma, I'm now going to do the restricted bracket. So I'm going to press ABC, side, the Desmos, and there it is. Squiggly looking bracket. And I'm going to restrict x to as being x is less than or equal to -1. And what that does is it takes this parabola. We should have had a parabola. That was the next squared. And it cuts it off at -1. Notice if I click the graph and I get to the edge, it's going to have more ink. Now, if I'd only done a less than, it would have less ink here because my symbol down here has less ink. It would have gone open, but that's not what we wanted. We wanted close. So again, that's how I could have known it was that way. Now for the second equation, I'm just going to do it on the second line. So I'm going to say 4, and instead of the comma, I'm going to use the squiggly bracket. 4 is restricted to being, where do you go, -1 is less than x, which is less than or equal to 2. So here's the second piece. Again, I'll click it. Notice it's open on the left, closed on the right. And then finally, the third piece of graph, 2x minus 5. And this needs to be restricted. So ABC side, there's a restriction, such that x is greater than 3. X is greater than 3. And if I click that and try it, notice I got to open, just like I do there, open at 3. And so that would be the correct answer. So that's by graphing. And if you want to use inequalities, that's how you would do so here. This being, I need to add that to the graph. Never did that. This one being that x less than x this way, which over here they did flip it around. But notice if you flip it around the inequality to the other side of x, you need to have it changed, which you can do it that way like that as well. And that's at the value of 3. And so that's why you can write it that way on the last equation. The last equation you can always flip around like that if necessary.